Hi guys, welcome back to our last phase of our lesson for today. That is, we want to solve the last two questions. My name is Peter C. Dagwa Jr., your math tutor, and I am also an instructor of mathematics at the University of Liberia. So in this lesson now, we want to solve question 11 and 12. We already solved question 7 to 10 in our previous lesson. So let's now look at question number 11, which is this one. We were asked to use natural logarithmic function method to solve this problem. So in order to use the natural logarithmic function method is to ensure that this problem is in logarithmic form. So to do that, we must convert it to logarithmic form by taking the ln on both sides of the equation. So we first rewrite this f of t by saying some y, replacing it with some y. So now we can rewrite this as well into exponential form. So we have t cubed plus 8 all over t squared minus 8 all raised to the power 1 over 4 because it is the fourth root. So now we can take the ln of both sides, ln of y, and we'll take the ln on both sides, ln of y. So we take the ln of t cubed plus 8 all over t squared is t cubed minus 8 raised to the power 1 over 4. So this 1 over 4 can come downward, so it becomes 1 over 4. So it's no longer here. Now this one now leads us to ln of a over b. Ln of a over b is just equal to ln of a minus ln of b. So it's ln of y. So it's 1 over 4 ln of a now, which is t cubed plus 8 minus 1 over 4 again, ln of t cubed minus 8. So we can now find the derivative. So it's 1 over y times the derivative of y, which is y prime. So this one now is 1 over 4. Differentiate ln of t cubed plus 8 is 1 over t cubed plus 8 times the derivative of t cubed, 3t squared. Derivative of 8 is 0. Minus 1 over 4 times the derivative of this one is 1 over t cubed minus 8. And the derivative of t cubed is just 3t squared. The derivative of 8 is 0. So we further simplify y prime over y is equal to, this is now 3t squared all over 4t cubed plus 8 minus, this is also 3t squared all over 4t cubed minus 8. So we find the LCD between the two denominators. Now, so let's remember that y is equal to this function. So we find the LCD. Now we have 4 in both, so we just take one of them, and then you have t cubed plus 8 times t cubed minus 8. Now, if this goes into this denominator, this and this will cancel, you'll be left with t cubed minus 8 times the numerator. So it's 3t squared times t cubed minus 8. Minus, if this goes into this will cancel, and this 4 will also cancel. You have t cubed plus 8. So it's t cubed plus 8 times 3t squared. So it's t cubed plus 8. Now, but t cubed is found in both terms, t cubed, so we can just factor it out. So it's t cubed, t squared now, not t cubed. So we'll be left with t cubed minus 8, and this side will be left with minus t cubed, and then this is also minus 8. Divided by 4, t cubed plus 8, t cubed minus 8. So this t cubed can cancel this one, And then 8 and 8 is 16. So this negative 16, negative 16 can reduce. This can reduce negative 16 4 here, 1 times 4 here. So it's minus 4. So y prime now is just equal to this y we cross multiply. So it becomes 3. Now this is already minus 4. So it's minus 4 times this 3. So it's minus 12 t squared y. That's a numerator. And then down here we have t cubed plus 8. And then t cubed minus 8. So we can bring in the value of y. So we know from the beginning y was just equal to t cubed plus 8, t cubed minus 8, all over 1 over 4. So where's where we see why we put that expression. So remember, each of them can be expressed, can be raised to their own powers. T cubed plus 8 raised to the power 1 over 4, and t cubed minus 8 raised to the power 1 over 4. So now this gives us 12t squared, and then we have t cubed plus 8 raised to the power 1 over 4, all over t cubed minus 8 raised to the power 1 over 4. But there's a denominator. So the denominator is just down here, which is t cubed plus 8 times t cubed minus 8. So now we can simplify. T cubed plus 8, t cubed plus 8. The power is 1 and the power is 4. So it's like saying 1 over 4 minus 1. So 4 times 1 is 4. So it's 1 minus 4 over 4. So this is minus 3 over 4. So this and this will give us a negative power. So y prime is equals to minus 12t squared t cubed plus 8 raised to the power minus 3 over 4. And then this and this. So the powers are the same, we must add them. So if we add them, it will be 1 over 4 plus 1. So 4 times 1 is 4 plus 1 is 5 over 4. So that will be t cubed minus 8 raised to the power 5 over 4. So this power is negative, we can reciprocate. So finally we can just have t cubed minus 8 raised to the power 5 over 4, and then t cubed plus 8 raised to the power positive 3 over 4. And what is left? Up there we have minus 12 t squared. So this is just our final answer. So let's do the last problem quickly. So the last problem says y equals to the root of x minus 1, x minus 2, and x minus 3. So again, we take the ln of both sides, ln of y, and the ln of this. But remember that this is x minus 1, x minus 2, and x minus 3, all raised to the power 1 over 2 because of square root. So we take this power, the ln of this side, x minus 1, x minus 2, and x minus 3. All raised to the power 1 over 2, but that 1 over 2 would drop behind this ln. So now, ln of a times b times c is equal to the ln of a plus ln of b plus ln of c. So we can apply this method. So ln of y is equal to 1 over 2, and then ln of x minus 1, the first factor, plus 1 over 2, ln of x minus 2, plus 1 over 2, ln of x minus 3. So we can now find its derivative. So this is 1 over y times the derivative of y, which is y prime, because y is the name of the function. And then this one now is just 1 over 2 times x minus 1. Times the derivative of this is just 1. Plus 1 over 2 times x minus 2 plus 1 over 2 times x minus 3. So we find the LCD right here. LCD is just 2 times x minus 1, x minus 2, and x minus 3. So each of these denominators can be taken from within this LCD. So 2 times x minus 1 goes into this cancel. Be left with that expression. So it's x minus 2 times x minus 3. Plus the same thing with this cancel, and this 2 also go out. You left with x minus 1 times x minus 3. And then plus this one goes out, and this 2. So you left with x minus 1 times x minus 2. So we can now simplify in the numerator. So y prime over y. So we simplify, you have x squared, x times 3 minus 3x minus 2x, and then positive 6, x squared minus 3x minus x, and then plus 3. And the last one, x times x, x squared, x times minus 2 is minus 2x. 1 times x is minus x, and then minus 1 times 2 is plus 2. All over 2x minus 1, x minus 2, and x minus 3. So we can simplify. 1x squared plus 1x squared plus 1x squared gives us, so we can cross multiply also. This y comes up here, so it's y. So this gives us 3x squared. 1s squared, 1s squared, and 1s squared. Then we move to x. 3x plus 2x is 5. Plus 3 is 8, 9, 10, 11, 12. So it's negative 12. And then 6 plus 3 is 9, 10, 11, plus 11. This is 12x. All over 2 times x minus 1, x minus 2, and x minus 3. But let's see as to whether this numerator can be factorized so that we can cancel something from here, just in case. No, I don't think so. Let's see. So it's 3x times 3. And then let's say 1 times 11. No, it cannot be. So 3 times 3 is 9. And then, sorry, this is just 3 times 1. So we cannot. This and this, it gives us something big. If we even put this 11 on this side and put this 1 here, we have this and this to be 3x, this and this to be 11. So even if we subtract, we're not going to get 12. Or if we even add, we're not going to get 12. So we just leave that. But what is y? Y was this expression. Wow, it's long. So remember, x minus 1, x minus 2, x minus 3, each of these factors can take their own power. So it's like saying x minus 1 raised to the power 1 over 2, x minus 2 raised to the power 1 over 2, and x minus 3 raised to the power 1 over 2 times 3x squared minus 12x plus 11 divided by 2x minus 1, x minus 2, and x minus 3. So what do we do? Now the powers here are all 1, 1, 1. So it's like the first one, 1 over 2 minus 1. So what will we be left with? We will be left with minus 1 over 2. So each of them will give us negative, negative, negative in the numerator. So for the first one, so let's deal with that one first. So it's 3x squared minus 12x plus 11. So this now and this gives us x minus 1 raised to the power negative 1 over 2. And then this gives us x minus 2 raised to the power negative 1 over 2. And the next one, x minus 3 raised to the power negative 1 over 2. All over 2. So finally, we can just say y prime, sorry, this is not y prime prime, equals to 3x squared minus 12x plus 11, all divided by 2 times x minus 1 raised to the power positive half, x minus 2 raised to the power positive half, and x minus 3 raised to the power positive half. So the same way each of them took their own powers, all of these can be expressed over 1, can be raised to 1 power 1, just 1. Just 1. Because we know that a raised to the power m times m over 2 times b raised to the power m over 2 is equal to ab, right? All raised to the power m over 2. That's exactly what it means. Especially when you have a square root. So the square root of a, which is a raised to the power 1 over 2, times a raised to the power 1 over 2. This is just equal to this is b. B raised to the power 1 over 2 is just equal to a b. Because when they are the same, then the root will go out. But when they are different, they will just combine. So now we can have y prime now to be 3x squared minus 12x plus 11 all over. So the first one now becomes 2, the root of x minus 1, the root of x minus 2, the root of x minus 3. So using this, the root of a times the root of b is equal to the root of ab. So even if we add the root of c, it's just equals to abc. So therefore, we can have y prime to be 3x squared minus 12x plus 11 all over 2, the root of x minus 1, x minus 2, and x minus 3. So this is actually our final answer. So in some cases, this method can be a bit long. In some cases, this method can be helpful. But whatever way you feel that is good for you, we can also use the extended power rule, drop this power 1 over 2, rewrite this entire thing, and we can differentiate each factor. So we hold this one, differentiate these 2. Let's say we hold 2 and differentiate 1, plus we hold another 2 and differentiate the second one, plus we hold another 2, the first 2, and differentiate the third one. that's it. So thanks so much for watching. Hope to see you in our next class. Thank you.